Hello students, let's see another question which came in GATE 2019 Civil Engineering. This was question number 44 in the afternoon session. So the question states that the uniform arrival and uniform service rate observed on an approach road to a signalized intersection are 20 and 50 vehicles per minute respectively. For this signal, the red time is 30 seconds and the effective green time is 30 seconds and the cycle length is 60 seconds. Assuming that initially there are no vehicle in the queue, the average delay per vehicle using the approach road during a cycle length in second round off to 2 decimal place is. The reference to solve this question could be found out in lecture 7 on intersection control and signalization in the course of Introduction to Transportation Engineering by Professor Bhargav Mehta, Department of Civil Engineering, IIT Kharagpur. So first let us write down what all data is given to us. Arrival rate is given to us as 20 vehicle per minute, which is stated as uniform, and the departure rate is given as 50 vehicle per minute, which is also stated as uniform. We have red time of the cycle as 30 seconds and the green time also as 30 seconds, and the total cycle time is 60 seconds. And we have to find out the average delay per vehicle during a cycle length, which is 60 seconds. So now let us plot all this data on a graph and try to get a solution to it. This is the arrival line, that is arrival rate 20 vehicle per minute would be the slope of this line. Let us call this line as line 1. This would be the departure line. Let us call this line as line number 2, and the slope of this would be 50 vehicle per minute. This axis would represent time. This axis would represent number of vehicles. So we have to find out the average delay. So delay would be this portion during which the vehicles are standing due to red cycle, as we have initially assumed that there is no vehicle in the queue before the starting of the cycle time. So we have to calculate first the area of the shaded portion and then divide by the total number of the vehicle in that cycle time. So first let us calculate the area of the shaded portion. So this is the condition what we have been provided by the question. The slope of this line 1 is 20 vehicle per minute and the slope of this line 2 is 50 vehicle per minute. Let this distance be x and this distance be y, and let us calculate the slope using x and y. So slope of line 1, that is 20 vehicle per minute, would be given as x by y. So x would become 20y, and the slope of line 2, that is 50 vehicle per minute, would be given as x divided by y minus 0.5, where y is in minute, because this distance is 0.5 and this whole distance is y. So this distance would be y minus 0.5. So if we do this, then x would become 50y minus 25. Let this be equation 1, this be equation 2. Comparing equation 1 and 2, 20y is equals to 50y minus 25, we get it y equals to 0.833 minutes, which would give the value of x as 16.67 vehicle. Now let us calculate the shaded area, which would be equal to half into this base y 0.833 into this x 16.67 minus this area, that would be half into 0.833 minus 0.5, this length, which would be equal to 0.33 into 16.67. If we solve this, it will come out to be 4.167 vehicle minute, which is the lost time. Now let us calculate the total number of vehicles arrived during the cycle time. That would be equal to 20 vehicle per minute into size of the cycle time, which is 1 minute, as it is stated as 60 seconds. So 20 vehicles have arrived during that cycle time. So average delay would be equal to lost time 4.167 vehicle minute divided by total number of vehicle, that is 40 vehicle, which will come out to be 0.208 minute. Let us convert this into second, which will come out to be 12.50 seconds. And we have to write the answer in second up to 2 decimal places. So the correct answer for this question would be 12.5 seconds. Thank you.